Thank you, Raj. I learned my wheat breeding from Dr. Rajaram, as Hans did and Ravi Singh. So thank you for the nice introduction. Ladies and gentlemen, distinguished guests, it is certainly an honor and a privilege to have an opportunity to give a presentation on the occasion of Dr. Borlaug's 100th birthday. The 21st century faces major food security challenges, environmental degradation, the loss of genetic resources, and the dwindling resource base. So these are addressed by CGIAR challenge projects, the Generation Challenge Program, and the Water and Food Challenge Project. Hidden hunger caused by micronutrient deficiency affects more than 2 billion people, and it's addressed by the Biofortification Challenge Program, HarvestPlus, which is a global alliance of, by now, more than 200 scientific and implementation partners in over 40 countries. So what can we do now? We have a number of interventions which complement each other. We can diversify the diet, but that's expensive and out of reach for many. We can fortify food, for example with iron, but people need to have an access to markets and buy processed foods. This doesn't happen in developing countries. And we can provide supplements, vitamin A, give pills to people, but then people need to have access to a healthcare system. So what does HarvestPlus do? Let's do the plant, do the job. We can develop wheat, rice, maize, and other staples and pack them with additional vitamins and minerals. And we have the nutritional benefits coming from the crops, harvest after harvest, at no additional costs, and also reach those which are not reached by other interventions. Now, HarvestPlus as a project started in 2004. We had an early discovery phase and activities focused on identifying target countries, target populations, and determine the cost-benefit of biofortification compared to other interventions. We engaged in setting the nutrition target levels for breeding and then assessed the genetic diversity in core collections, in the gene banks, in the tactical strategic gene pool for a wide range of crops, looked which crops lend themselves to biofortification, and also in parallel had to identify, for example, selection environments for minerals, and also trade diagnostic tools. Once we knew that, we developed crop product concepts. Now in this process, what did we learn? India and also Pakistan were identified as initial target areas for high zinc wheat and zinc as a target trait. Now, why India? In India, more than 55% of women and children do not receive health care or nutrition intervention. Despite of really a fantastic economic growth, the number of children which suffer from wasting, stunting, and malnutrition has not declined significantly in the last 2 decades. So yesterday we did hear about a percentage decrease, but in absolute numbers there was no decrease in children suffering from malnutrition. Within India we identified 2 target areas, the Eastern Gangetic Plain Zone, where most of the wheat is consumed on farms, so we reach the rural population, and the highly productive Northwestern Plain Zone, where most of the wheat is procured by the government and then goes into the cities. So also we reach then those who are deficient in the urban areas. In setting the target for breeding, we came up with that we have to add 12 parts per million, micrograms per gram, ppm, to a baseline for zinc, which is approximately 25 parts per million in commercial crops. Now what If we add 12 ppm of zinc, what will they do? If you look at the requirement for women in childbearing age, if we add 12 ppm to wheat, we can achieve a 70 to 90% requirement satisfied depending on the intake level, which varies also within India. It is a bit lower in Punjab, it is higher in the Eastern Gangetic Plains. If we add a higher level of zinc, let's say 16 ppm, we can achieve almost 100%. What did we learn in germplasm screening? We looked at more than 20,000 genotypes. And the good news was that we had a variation to surpass the target in wild relative species, synthetic wheat. That was the good news. However, we didn't have any latent variation in the technical gene pool in adapted germplasm. So the breeders had to go through pre-breeding and parent building, and this added time to market in product development. But you can see the levels are extremely high, and wheat can come to levels for iron and zinc, which is close to the legumes. And different from common belief, wheat is a nutritious crop, and it's superior to the other megastaples, to rice, to wheat, or to cassava. The roots and tuber crops are extremely low in micronutrients, and they have protein levels below 10%. So that's the selling point for wheat, Hans. Where is zinc located? It's mainly in the embryo, aluron layer, endosperm. Was the wrong button. And there is co-localization of zinc, iron, protein, and amino acids. So this explains the correlation between protein and minerals, and also iron and zinc. So if you increase iron, you also increase zinc, and vice versa. Within the grain, where is the zinc located? It is in the embryo, as you can see here, the color staining on the right side. And it's where you have the grease around the vascular bundles. In the second phase of HarvestPlus, the development phase, we focused on crop development. We have to have competitive crops. You cannot see zinc. It's invisible, and it doesn't affect sensory traits. So we have to combine zinc with other traits which do adoption by the farmers and required traits such as UG99. In the next step in crop development, once we have crops, they were tested in the target countries, and along with the testing on farm, on station, PVS, we also conducted trials to develop crop management recommendations. Now, biofortification is an evidence-based intervention linking agriculture and nutrition. And before we can give crops to farmers, we have to generate the nutrition evidence that if people consume biofortified crops, there is a measurable, meaningful impact on their nutrient status. And so in parallel, we have to conduct nutrition retention studies, bioavailability studies, and also efficacy trials in humans. And this happens all in parallel. In the phase we are in now, the delivery phase, we have now crops developed, and activities focus on commercialization, marketing, awareness campaigns, demand creation. If an increase in vitamin A causes a color change, like in the case of maize or sweet potato, we also have to conduct acceptability studies towards our goal to develop sustainable markets for the seed and for the grain. So we need to generate demand. We do branding, we do marketing. This is the Shaktiman logo we developed for Pearl Millet, the Power Man. And we are in the moment testing this Shaktiman, whether it's suitable also for wheat. Yesterday, several speakers talked about advocacy, and that's absolutely critical. Without a buy-in from the government, we are not getting anywhere. And so we have to engage in advocacy, project visibility, and also in talking to ministries of health, ministries of agriculture, to include biofortification international policy. Looking at the question if biofortification will work, the question number one we had to address was, can breeding increase the nutrients to levels that improve nutrition? By really pushing very hard on reducing time to market, we have now releases for all the crops we had concentrated on in the first phase. Sweet potato in 27, cassava, beans, maize, pearl millet, and rice. And this year we started the test marketing 1,000 mini kits of wheat, for wheat we don't release because we can commercialize in India as truthfully labeled seed. Now, if you release a variety, it has to go through a registration process and be competitive with non-biofortified crops. So it shows that these crops also have economic attributes which farmers prefer. In parallel, developing these vital products, also the breeding programs in national programs at CIMIT assumed the critical scale. If we also include investment level 2 crops, lentils, potato, cowpea, banana, plantain, and sorghum, then by now we have releases in 27 countries. And we are testing the crops in 43 countries in Africa, Asia, and Latin America. The second question we have to address is, are these extra nutrients we include, are they bioavailable at a sufficient level to improve the nutrient status in humans? And starting in 2008, we looked into how do we know that zinc wheat works, conducting studies on the intake. Do we really have intakes of 250, 300 grams in India, Pakistan, other countries? What is the retention when you produce local food, for example, chapati? Retention for zinc in that case was 95%. And also we could answer the question and demonstrate that zinc in biofortified wheat is bioavailable, absorbed, and utilized. In this case, we used animal and human models. Currently, we have 2 trials going on in India. One is a very large-scale trial to determine if zinc wheat consumption improves the zinc status of women and children. In one trial that's in the slums of Delhi, we have 1,500 children involved and 1,500 women in childbearing age, so a total of 6,000 subjects. We need 600 tons of wheat, which is packed, as you can see below in these packages. They are coded. And the feeding trial goes on over a 6 months period. Now, a positive outcome of this trial is absolutely critical, because we need to have this nutritional evidence. Otherwise, we cannot do any nutrition claim. Also, we need it for branding, for marketing. You cannot put anything otherwise on your pack. But it's also extremely important to have nutritional evidence for advocacy. If I go to the Ministry of Health and say, look, we have this excellent high zinc wheat, you should use it, include it in your policy, then they said, what is the evidence? So again, all these activities have to be timed. So the nutrition studies, advocacy, as you move along. And now when we have the results, hopefully published in late 2015, then we can stronger engage in advocacy. The third question we had to address was, will farmers adopt zinc wheat and consumers buy and eat the wheat in sufficient qualities? By now I can't answer the question for wheat because the mini kits, 1,000 mini kits are still out in the field. They will be harvested in April in the Eastern Gangetic Plain Zone. But we have evidence from other crops. To date, we reached approximately 1.5 million farming households with a range of crops, mainly high iron crops in Rwanda, Congo, India pearl millet, vitamin A crops, sweet potato, cassava in Nigeria, and just shooting for 2014 at 25,000 farming households for wheat and 22,000 for rice. So it will be the first year. Planting will be in 2014, 2015. We look at a total of 1.5 million household target for 2014. In this effort, we have very strong, excellent partners. Many of them are here in the room. Public sector. This is for India, similar will be for Pakistan. DWR, ICAR, Dr. Fabandata is here, IRI, PAU, BHU, and at its nexus in crop development, CIMIT. We are engaged in crop development and testing, and then we have partnerships in testing and or commercialization from the private sector. We have, at the moment, 14 companies. Now, in the moment we are discussing with these companies commercialization issues. In the moment there's no profitable market for high zinc grain. So what we have to do also in those discussions, negotiations is de-risking the business for these companies, make it attractive, help them in awareness campaigns, in promotion, providing marketing collaterals, and so forth. Now, in the future, what is the way forward? What do we need to achieve in the next 5 years? HarvestPlus priorities for 2014 to 2018 are to demonstrate the viability of biofortification as a global solution and lay foundation for scale by scaling up delivery in target countries and expand delivery to new countries. Then strengthen the pipeline of biofortified crops and research, communicate, and advocate strategically. Again and again, advocacy. It came up yesterday as being very critical in the next years to engage more in those activities. In scaling up delivery in target countries, in our current target countries, we operate in the moment in 9 countries. We implement the country-level business plans and try to, again, secure funding to complete the different stages of delivery. When you start in a crop, you have an introduction phase, a saturation phase, where we try to achieve market shares of up to 70%, for example, for bean in Rwanda. For wheat, we try to achieve by 2018 about 4% in Uttar Pradesh, a market share. And then later have an anchoring phase where the government takes over and HarvestPlus can phase out. In new countries, in expansion countries, we plan to deliver through partnerships. You can also call it the non-HarvestPlus delivery. And one of the activities will be to deploy technical assistance capabilities to support those partnerships. Yesterday we also talked, and Mr. Buffett, about involvement of different partners, NGOs, and that's a kind of a quick assessment of the relative role and value of the main partner groups. HarvestPlus is engaged all along the value chain in the moment, and that's a big advantage of the program because we can address bottlenecks and take necessary action. So in case of delivery in our current target countries, we set up these public partnerships with public, private sector, NGOs, depending on the crop. We have different marketing situations. Let's take maize as an example. Hybrid maize in Zambia. In that case, we operate with private companies. They are interested, maize is a commercial crop, and you can see they can do everything. the moment that breeding released, these are varieties developed by CIMMYT, Kevin Pixley and his team, Natalia Palacios, Tanda, and now multiplication of seed and the rest, that's now with the private companies. So they can take over a crop completely. They can then move now from Zambia, let's say, to Malawi, commercialized there. Another extreme would be a situation where you have social marketing. Take DR Congo. There is no private sector. When you look in the USDA value chain report, they say there is no value chain. So we have also in those countries to try to establish the private sector and help them getting up to have sustainability on the longer term. And you have sometimes this mixed situation, social, commercial marketing. So again, you can see there are different strengths. NGOs, for example, they are strong in farm extension, demand creation, advocacy, but they have no expertise here in breeding and release. And so we have to link them up, provide technical assistance to cover that part. So this will depend on crop and country. In the Economic Forum in Davos, HarvestPlus announced an umbrella agreement with World Vision, so it's one of the major global NGOs that operate in more than 80 countries. It was the first one of many. And so in the future, they will completely take over. In terms of breeding, what are the plans for the next 5 years? We have to develop the next wave of biofortified crops, breed competitive crops, and also with wider applicability, wider adaptation to different agro-ecological zones and uses. Enhance our knowledge base in uptake and translocation of micronutrients, and deliver improved enabling technologies, mainly molecular markers, other diagnostic tools. This is absolutely critical to improve the breeding effectiveness for micronutrients on one side, and also to achieve mainstreaming of the biofortification trade. If we want to use iron and zinc as non-negotiable trade, as core trade in breeding, we need molecular markers to be effective. Just good news, which came last week from a meeting of the Center DGs in Tanzania. All the Center DGs, Dr. Lampkin is not here, Dr. Mahmoud Sol is here, they endorsed mainstreaming of biofortification in their breeding programs. Another challenge will be improving the bioavailability of iron and zinc, especially for iron. Why? For zinc, we have bioavailability of 20%. For iron, only 5%. So in this case, we have to have a strategy where we shoot at both, raising the concentration of iron and at the same time increasing bioavailability. We look into anti-nutrients and promoters like phytate and phytase. You saw in the field, probably some of you, there are now some lines CIMMYT is working with, they are high in phytase, and so there is some variation available to get started. With this, I'm at the end of my talk. Thank you.